Hello and welcome all to the video lecture. Myself Dr. S. M. Prakash, Assistant Professor, Department of Chemistry, St. Joseph College of Engineering. So the topic of this lecture is Freundlich Adsorption Isotherm. This topic comes under the unit Surface Chemistry in the subject of Engineering Chemistry. So before entering into this topic, we need to know and understand some terms and what adsorption isotherm is. So the important terms are nothing but the adsorption, absorption, sorption, adsorbate and adsorbent. So first of all we are going to discuss about the important terms. So the first one is adsorption, AD. Adsorption. So adsorption is nothing but that's a surface phenomena. So the phenomenon of concentration of molecules of a gas or liquid at the solid surface is called adsorption. Then what is the absorption? AB. Absorption. So adsorption is the surface phenomenon and then absorption. Absorption is called a bulk phenomenon. So absorption is a process in which the substance uniformly distributed throughout the body of the solid or liquid. That's called absorption. So let us see an example. If you are dipping a rubber ball into a paint, that paint will be coated over the rubber ball. So it's concentrated only on the surface. So paint cannot be diffused into the rubber ball. So inside of the rubber ball. So this is called adsorption, AD. That is a surface phenomenon. And then absorption, for example, if you are dipping a sponge into the paint, that paint can diffuse into the sponge. So the paint can uniformly distributed throughout the sponge. So inside of the sponge. So that process is called absorption. Then what is a sorption? That's another one important term. Sorption. So sorption is nothing but if adsorption and absorption take place simultaneously, that is called sorption. Sorption, right? Then the important two things we need to discuss to understand about adsorption AD. That is nothing but they are adsorbate and adsorbent. Adsorbate and adsorbent. Then what is adsorbate? First of all, we are going to see adsorbate. What is adsorbate? So adsorbate is nothing but the gas molecules, a gas or liquid which held on the solid surface. The gas or liquid. So that means a substrate. The substance which are held on the surface of the solid is called adsorbate. Then adsorbent is nothing but that solid. The solid which takes up as gas or a solid from the solution, that's called adsorbent. Right. So we can see an example, a diagram for those things. We can explain these all things with a diagram. So let us imagine if you are putting a solid into a gas. So that gas molecules are there. There are number of gas molecules. That gas molecules adsorbed on the solid surface, that is called adsorption, AD. That is a surface phenomenon. So this is example for adsorption, AD. Right. So the gas molecule just concentrated on the surface of the solid. So gases are not diffused into the inside of the solid. So it's only concentrated on the surface. So this phenomena is called adsorption. So we can see the another example for this process, that means for absorption, AB. Absorption. So in this absorption process, so the molecule can diffuse into the inside of the adsorbent also, that means solid. So this process is called absorption AB. Then we are going to see an example for sorption. Sorption is nothing but if both adsorption and absorption takes place simultaneously, that is called sorption. Here we can see the gas molecules, that gas molecules concentrated on both sides, that means on surface, also in the bulk process. So in also the gas molecules are diffused into the inside of the solid. So this is the example for sorption. Right. Next, we are going to see what adsorption isotherm is. Adsorption isotherm is. So adsorption isotherm can be defined as a relationship between the magnitude of adsorption, that is x by m, that means the extent of adsorption, we can say extent of adsorption or magnitude of adsorption and pressure. Right, adsorption isotherm can be defined as the relationship between the magnitude of adsorption, that is the extent of adsorption x by m, and pressure. Here x is nothing but mass of the adsorbate and m is the mass of the adsorbent, mass of the adsorbate and mass of the adsorbent. So the extent of adsorption, that means x by m, is depend on both pressure and temperature. X by m, that means extent of adsorption or magnitude of adsorption, depends on both pressure and temperature. Both pressure and temperature. So we can explain this relation using a simple graph between x by m and p, that means extent of adsorption and pressure, extent of adsorption and pressure. So we can draw a graph. Here pressure P is marked along the x-axis and extent of adsorption, that is x by m, marked along y-axis. So here we can get a curve. So here we can see the rate of adsorption, that means extent of adsorption increases with the increase of pressure. So rate of adsorption increases with the increase of pressure. So adsorption depends on pressure. At a certain point it becomes maximum, at certain points it becomes maximum. That point is named as PS, that point is named as PS, which means saturation pressure, which means saturation pressure. At this point, saturation pressure, the rate of adsorption remains equal to the rate of desorption. Hence, a dynamic equilibrium is established between the adsorption and desorption. Adsorption and desorption. That means the free gas molecules are in equilibrium state with the adsorbed gas molecules. So a dynamic equilibrium is established between the adsorption and the desorption. If we further increase the pressure, that means if we alter the pressure furtherly, if we raise the pressure further, it doesn't alter the attained equilibrium. That means it will not adjust the adsorption. So adsorption becomes constant here. So this relationship can be expressed mathematically using a empirical equation, that is x by m is equal to kp power 1 by n. So this empirical equation is known as Freundlich's adsorption isotherm. This x by m equal to kp power 1 by n is known as Freundlich's adsorption isotherm. Okay, we can continue now. So in 1909, in 1909, Freundlich explained a theory on adsorption isotherm. In 1909, Freundlich explained a theory on adsorption isotherm. In his theory, he explained how the adsorption takes place at a constant temperature and at varied pressure. At constant temperature and at varied pressure. Here, monomolecular adsorption takes place. That means monolayer of adsorption takes place. The general mathematical representation of for gases at normal pressure is given as x by m is directly proportional to p power 1 by n. X by m, that means extent of adsorption directly proportional to pressure p power 1 by n. So this proportional relation can be converted into equation by introducing a constant, that is k. So this equation become x by m equal to kp power 1 by n. That constant k is called rate constant. That constant is called rate constant. So here n is also another constant. It must be greater than 1. It must be greater than 1. So this equation, for this equation we are going to take logarithm. We are taking logarithm on both sides of this equation. That equation become, we can get log x by m equal to log k plus 1 by n log p. 1 by n log p. So this equation is similar to an equation for a straight line, that is y equal to mx plus c. So here we are taking that log x by m as y, and then log k as c, log k, and then m 1 by n as m, and then log p as x. Right. So we are going to plot a graph for this equation. So we can get a curve. So here the pressure, that means log p, is marked along the x-axis, and then extent of adsorption, that is log x by m, is marked along y-axis. So we can get a line, straight line. That line joins into the at a y-axis. That line, that straight line, joins at a y-axis. So this gap is called intercept. Its value is log k, and then we can get a slope for this line. That slope value is 1 by n. So this is called adsorption isotherm, Freundlich's adsorption isotherm. So that Freundlich explained this relation adsorption isotherm with 3 conditions. So condition 1, at low pressure. Condition 1, at low pressure. So in this low pressure, the adsorption is directly proportional to the pressure. Adsorption is directly proportional to the pressure. That means x by m, that means extent of adsorption directly proportional to the p power 1, or x by m equal to kp. Here adsorption increases with increase of pressure. So adsorption depends on pressure. So if we alter the pressure, adsorption will be changed. If we decrease the pressure, adsorption will be reduced. If we increase the pressure, adsorption will be increased. So adsorption directly proportional to the pressure. Adsorption alter with the pressure, right? And then at high pressure, At high pressure, adsorption is almost constant. So there is no change in the adsorption. There is no increase or decrease in the adsorption if you are altering the pressure, if you are changing the pressure. So adsorption is almost constant. So x by m is directly proportional to P naught, or x by m equal to K. So it's almost constant. So adsorption is independent to the pressure. Adsorption is independent to the pressure. So we cannot alter the adsorption by altering the pressure, by changing the pressure. That's called the second term, second condition. Then in third condition, at intermediate pressure, at intermediate pressure. So in this intermediate pressure, so Freundlich state that the extent of adsorption, that is x by m, is directly proportional to p power 1 by n, or x by m equal to kp power 1 by n. So here n is the whole numbers, n is a whole number which depends on the nature of both adsorbate and adsorbent. So the 1 by n values must be lies between 0 and 1. That means it should be a fraction, 0 to 1, it should be a fraction. So next we are going to see the limitations of Freundlich's adsorption isotherm. There are some limitations, so we are going to see them one by one. So limitations. So Freundlich failed to explain this adsorption isotherm at higher pressure. Hence, this relation is only valid with a certain pressure. So at high pressure it is failed. That is the first point. So at high pressure it is failed. At high pressure it is failed. So this equation, this relation is valid only up to a certain pressure. That is first point. Then second, as this equation is purely empirical, it has no theoretical basis. It is purely empirical. And has no theoretical basis. And then third, the constants K and N are temperature dependent. They vary with the temperature. If you alter the temperature, which affect the constants value K and N. That's why we are taking place the adsorption isotherm at a constant temperature. So it depends on only pressure, not temperature. So because these constants K and N are temperature dependent, they vary with the temperature. If you alter the temperature, which affect the constant values K and N, rate constant as well as that N value. Then third, fourth, and finally that Freundlich adsorption isotherm fails when the concentration of adsorbate is considerably very high. If you are taking high concentrated adsorbate, so we cannot find out the Freundlich adsorption isotherm. So it will be failed. So these are some limitations of Freundlich adsorption isotherm. Yeah, now we are at the end of the session. In this lecture, we have discussed about some important terms like adsorption, absorption, sorption, adsorbate, and adsorption isotherm, including Freundlich adsorption isotherm, and how the adsorption takes place at a varied pressure. I hope this is useful for you all. Thank you.